This is part 2 of factoring quadratic expressions. We'll move on to example number 4. I have 2x squared plus 10x plus 12, and I'm trying to find the greatest common factor. In this particular case, I realize that my greatest common factor of all the terms is 2. Now, what I want you to realize is that I am interested more, for everything else that's about to happen, in the x squared plus 5x plus 6 quadratic expression that is remaining. So I guess the answer to this question is yes, it is. And when I start looking at my A, B, and C, I'm not going back and looking at the original problem. I'm going to go ahead and look at my A from, the fact that it's 1x squared plus 5x and plus, or C equals 6. And so when I'm looking at breaking up the middle terms, I should be focusing on two numbers that multiply up to 6 and two numbers that add up to 5. And I have found that those two numbers happen to be both 2 and 3. So when I start writing out my middle term, one of the things that you have to understand is that the 2 is one of the factors. But what I'm going to be really focusing on is dealing with the x squared plus the 2x, which comes from this number here, plus the 3x, which comes from this number here, and then the plus 6. So yes, I'll write out 2, but when I'm looking at the greatest common factors of these two pieces, and we'll go, I'll pull out an x, leaving me with an x plus 2. Then I will look at the greatest common factor of these two pieces, and knowing that x plus 2 has to be in both of them, I'll pull out a plus 3 of those two terms. That's the greatest common factor. And so I can write x plus 2. I can also write x plus 3, but I also don't want to forget the 2 that I had initially, and that would be my 3 factors for this particular quadratic expression. Example number 5 starts off a little differently because now our A is negative 6x squared. And my suggestion is, and because it makes it a lot easier, is that if your A is negative, then what you want to do is pull out the negative as well as any other greatest common factor. Maybe the greatest common factor is 1. You'll pull out a negative 1. But in this particular problem, I am finding out that my greatest common factor happens to be negative 3 if I pull out the negative. And when I'm losing, there we go. When I pull out the negative 3, I'm left with 2x squared minus 13x plus 20. And so I'll be looking at the numbers 2, negative 13, and 20, and realizing I need two numbers that multiply up to 40, because that's what 2 times 20 is, and I need two numbers that add up to negative 13. And those two numbers happen to be negative 8 and negative 5. Negative 8 times negative 5 is 40, and negative 8 plus negative 5 is negative 13. So, again, the negative 3 is part of the factors. But when I break up the middle term, I really just want to write 2x squared, use my negative 8 as a linear term, so negative 8x, use negative 5x as the second linear term, and then put 20 at the end. Once again, negative 3 is always part of the problem, but if I'm going to now follow the greatest common factor of those two pieces, I will realize that I guess I can pull out a 2x. This will leave me with an x, come on, here we go, x minus 4. Knowing that an x minus 4 has to be over here, this will help me understand I should be pulling out a negative 5 and not a positive 5. And once again, x minus 4 is what's common in those two terms. I should have highlighted this just in case you want to see it. Then I would have had 2x minus 5 being another one of the factors, and then I don't want to forget the negative 3 that I had at the very beginning. And so I move on to my last of my factoring examples, example number 6. It looks very simple, x squared plus 12x plus 36. There is no greatest common factor, so that is 1. Not really helpful, So yes, there's still a quadratic expression. A happens to be 1, B happens to be 12, and C happens to be 36. So what two numbers multiply together that equal 1 times 36, which is 36? And at the same time add up to 12? Well, what you're going to find out is that they are the same number twice, 6 and 6. So if I'm going to write down the middle term and go x squared plus 6x plus 6x plus 36, I'll want to look at those two terms. I'll want to look at those two terms, technically include the plus there as part of that grouping. Realize there's an x that can come out of the first two pieces, leaving me an x plus 6. If I know that I have an x plus 6 over here, then that will help me realize that I should be pulling out a positive 6 of those last two pieces. Now this is sometimes where it gets a little confusing. These two make up this one factor, x plus 6. It just happens to be that the other pieces, the two greatest common factors of the two groups, also make up an x plus 6. So it's not that there are 3 x plus 6 quantities, but only 2 of them. You can actually rewrite this as x plus 6 quantity squared, which leads us to another vocabulary term that you should be aware of. When you have a quadratic, and I'm going to just write the original problem. Give me 1 second here. Oh, there we go. When you write the original quadratic, x squared plus 12x plus 36, we can call this a perfect square trinomial because literally its factors is the same factor squared. And you can tell immediately when that happens when you look at the two numbers that you come up with, and if they're identical, that will lead to a perfect square trinomial. And that brings us to the end of factoring quadratic expressions.